friends and curious folks out there. Welcome to part 3 of the rise and stall of the piston engine. Part 3, we never needed petroleum and never will. So let's get started. This is a big subject, one that's sure to raise a lot of controversy. We didn't need petroleum in order to have electrified cities and factories, cars, ships, and flying machines. That's why I'm saying we never needed petroleum. I'm not trying to say we could have been farmers for the rest of our years here on this planet. We could have still had all the things that we have now. That's what I'm going to show. And the reason, number one reason, the abundance of coal. Now, I'm not saying I'm advocating going back to coal. I'm not advocating going back to the coal days. What I am explaining is that we never needed to go from coal to petroleum. These workers that put in this time, some real men. I have nothing but respect for these coal miners. And these guys have done their time, and I want to go back to having this kind of a solution to our current energy dilemma. What I'm saying is that the process of going from coal to crude oil represented no gain in technology. In fact, the removing of electricity from our tracks and roads moved us backwards in technology. Coal is a very plentiful resource on this planet. There's one advantage to using coal over using petroleum. That advantage is the fact you can use it basically as it is, scooped out of the ground. And that means you don't need to process it other than to crush it up a little bit, but you don't need to cook it, you don't need to refine it, you don't need to put it into different tanks, you don't need to distill it, you don't need to have pipelines. That's why we didn't move forward when we went from coal to petroleum. If anything, we moved backwards. And here's a large coal mine. Look, it does some damage too. I'm not denying that. And I'm not trying to say this is the ultimate solution. I'm just trying to say we gain nothing by going from this technology to the technology that we have now. Because look at coal. Look what you can do with coal. You can make synthetic gas out of it. You can make methanol. You can make methyl acetate and acetic anhydride. And from this you can make virtually, well, you can make every product that we need to manufacture from petroleum or crust-produced crude oil today. We've got diesel and naphtha up here. We've got gasoline actually coming off, first producing methanol and then producing that into gasoline. Boy, what a dumb idea that is. But hey, if that's, you got to have gasoline, then that's one way to make it. But you can make everything from coal. Now this, from 1910, this is a steam generator. Okay, we got a steam turbine here, 2-stage. We've got an electric generator here. And this was invented as early as around 1874. But folks, understand, the day this was invented, that was the day that it was lights out for crust-produced liquid crude oil, because this ran off steam. And in order to make steam, all you need to do is boil water. And how do you boil water? With anything that'll burn. This provided a way to get energy anywhere, basically, on the planet by using copper wire to get it there rather than to truck it there and use pipelines and things like this. Now imagine if today all of our highway system was an electrified grid like it should be and like it was at one time in major cities in the United States and across Europe. We would be able to stop carrying fuel. We would be able to stop filling up with fuel. We would be able to stop polluting the downtown. We would be able to get rid of service stations. We would have no more tank farms. We would have no more pipelines. That's a major improvement. That's a win for the environment. Now let's go back to even further back beyond coal to simple biomass energy. And biomass is anything that will burn that's of a mass structure. It's a solid, like wood. And it's the simplest form of agricultural energy use. It is the direct combustion of cellulosic crops or residues such as hay, straw, or corn fodder. And after all, we're just trying to produce steam. So the energy game is over. We've got to stop letting them tell us and make our lives worrisome because we think we're on this little thing, the crude oil curve, and whatever the price of crude oil is, that our prosperity goes up and down. This is absolutely absurd. They've got the world consumption now up to 96 million barrels a day, and I calculated that out to where this is what they claim that the world is using in petroleum. 2.8 million gallons a minute, 6,000 cubic feet a second. Okay, so how much flow is that? I tried to find a pipeline. You need a 32-foot diameter pipeline at full flow, 24/7. And this is a 21-foot pipeline. It's the biggest one I could find. So it would be 1.5 times this size, which would be actually 2.2 times the surface area or size. Flowing oil, worldwide demand, 24/7. This is utterly absurd. You know, they talk about global warming. Here it is, folks. If global warming is real, by the way, let's not go there. 1 ton of coal, did you know, equals 188 gallons of oil? In 1912, when the Titanic was sunk, the commercial price of coal was only $1 per ton. So she could cross the ocean on 3,000 tons, and that meant hauling 3,000 passengers, that each passenger was transported across the Atlantic in total comfort with steam baths and heated rooms and lobster and cappuccino and whatever you wanted. It only cost them $1 per person in energy costs. Now that is a great invention. The Titanic was it was a marvel, and as were all the steamships, especially for their day. Advanced transportation was actually in effect by 1850. We had advantages using coal, as I mentioned, and it was just scooped from the ground, no processing, no tanks, spills, disasters. It was abundant, very cheap, and we also had a process which you may have not known about called coal gasification. And this is where if you want to convert your coal into a gas or a liquid, this is how you do it. And it's called pyrolysis. It's a thermal decomposition of materials at elevated temperatures in an inert atmosphere such as a vacuum gas. It transforms the organic materials into their gaseous components, a solid residue of carbon, ash, and a liquid called pyrolytic oil or bio-oil. So this is just the simple gasification of coal, and so we're going to add that into the simple biomass energy equation. We've got cellulosic crops or residues now, such as hay, straw, corn fodder, that can be converted to a gas or liquid by pyrolysis, just as coal can. Or what's even simpler, you can burn it as is, produce steam that way, or you can burn it as is to heat buildings and commercials in rural areas. And it can be utilized for like the drying of crops. Like let's say you're making scotch and you need to dry your hops after you've sprouted them, and you're going to need some energy to speed up your drying process. Why not just use the leftover material from last year? Burn it directly. Well, of course, we don't do that because of environmental laws. What we do is just allow them to use petroleum everywhere with leaky tanks and pipes and toxic car exhaust, etc. That's okay, but don't go burning your waste, leftover grass in order to get some energy out of it. So moving on, again, why we never needed petroleum, because we had coal, but not only that, we had coal gas, and we had coal liquid, and we had wood waste, and we had methanol and ethanol from fermentation. We had biomass such as peat, grasses, rice hulls, coconut husks, etc. We had bioliquids like coconut and vegetable oils and animal fats. Believe me, this was plenty to keep our country running, to keep it running as mechanized. In fact, as you'll see, it'd be even more mechanized if we had just taken advantage of electricity. Here's a schematic of a vegetable oil refinery. There is such a thing. Oil is obtained either from a solvent extraction or from an expeller, and they put it through a process to remove impurities. And you can also turn these different types of vegetable fats into lubricants. You can turn them into fuels. And if we look at all the different types of natural oil, such as safflower oil leading all the way down to coconut oil, and look at the fatty acid content, you know that we get just a terrific variety here on this planet. We can have low saturated, we can have high saturated, depending on mono unsaturated in the yellow or saturated in the green. And then we've got omega-6 and omega-3 in these here. So everything that we need, a tremendous variety, is here already. So look at all of these oils again. There's a comparative analysis to carbon length, and you see that a lot of these oils will substitute right in for current petroleum products that we're using. Number one is fuel. How are we going to make all this fuel? Well, we talk about coal, we talk about gasification of coal. We could take all of these animal fats and either turn them into a fuel using like a biodiesel process, or we can actually use pyrolysis on them as well and convert them into other kinds of liquids. So let's move on. We're just getting started here. We can take a look at the comparative analysis of fuel. The coconut oil that I've got circled here, has about the highest millijoules per kilogram of all the oil. And if we look at diesel fuel up here around 45 and gasoline at around 46, you'll notice they are higher in energy content than the oils are. But the oils are comparative. The oils will work. I'm not saying they have quite as much energy, but when we turn these into biofuels, they produce nearly the same amount of fuel mileage as the straight petroleum product. So here's just another area to obtain propulsion power. So again, here's the small steam plant that I showed you before. In actuality, today, this is what a modern steam plant looks like. This would be a view of the inside of it, the steam turbines here. This is currently the state-of-the-art way to power the planet. You burn something, you produce steam, you run the very efficient steam operation, you convert it into electricity. So let's see, what could we have done with electricity? In 1879, we had the world's first electric train. I realize this isn't huge, but look at all the people that it's moving around. This is 1879, moving people pollution-free. And I might add that, using electric technology, that's way above mechanical piston technology, believe me. In 1890, we're looking at a London Underground subway here. 1906, electric locomotives for the first time in New York Central Railway, and each axle directly driven. There's an armature mounted on each axle. Moving along to 1913, now we've got a 2,400 volt electric automotive, and it went into operation on the Butte, Anaconda, and Pacific Railway in 1913. So this was like the first commercial electric freight train. What else did we have? We had all these electric vehicles. Baker, Studebaker, Hoffman. Did you ever hear about these? No, because they're the best kept secret. But these were all in the years from 1896 up to about 1920. We had a huge number of electric car manufacturers, and they were quality built, and they especially appealed to the rich because they were so reliable. 1895, here we are in London, 1895. This would be your method of travel by horse and in a buggy with a professional driver. Now, is that such a bad ride? You're going around, say you're going around San Francisco in this, or New York in this. Is that such an undistinguished ride? Do you feel low? Do you think this is any slower than a taxi cab in traffic? So, I mean, that's just a thought. Just a thought. That's what we're here for, is to share thoughts. These oil companies didn't play fair. They bought out all the carriage manufacturers. They converted them to car manufacturers. They created a carriage shortage. They drove the price of carriages up above the cost of automobiles. There was such a shortage. That's what happened to the carriage. These guys were determined to get our horses off the street so we could have stinky cars down there in City Central, giving everybody carbon monoxide poisoning on the first and second levels of the city. When actually what we should have been going toward, and we did, we went into the cable car and the electric car. This looks like a cable car here, Maine, Delaware. Let's see. The cable is underneath, and it's being driven by this mechanism here. The cables are actually underneath the road. So your mechanism pulling your cable cars is out of town, or it's at one end of town, and it's running on electricity, and the electricity is coming from a power plant that is most definitely out of town. So there's no pollution. You've got perfectly clean air. And I might add, we had some other nice gadgets around the turn of the century too, when we got this great supposed petroleum, supposedly got a higher level of society. Here's the famous Cunard liner Aquitania. And here's one of the most famous locomotives ever built, the Baldwin locomotive. This, by the way, is out of the 40s. The Cunard liners, these were built, these were right before the Titanic. These each had 4 turbine engines in them. This held the record going from New York to London. These held the record. They could do about 26 knots. The Titanic could never equal the speed of these. Anyway, we had some really nice gadgets. By the way, this railroad was reputed to be able to go 150 miles per hour. This was in 1940, running on coal. Let's look at some other inventions. We had the Hindenburg, which was diesel powered. Now, if it's diesel powered, you can run it on any of those vegetable oils we were talking about. I was showing you earlier. So she could have run on vegetable oil, tallow, lard, alcohol, or a combination. Or, if your worst comes to worst, throw some petroleum in there. But, use that as a last resort. Overland Limited in 1906 was a coal train that went from Chicago to San Francisco. It ran on coal, had a dining car, it had a cabin, it had a reading lounge, it had showers, and it took about 60 hours. Okay, yeah, that's a little slower than flying by air today, but it's such a better ride, and you're so much safer, and you don't have to go through the agony of an airport and leaving the ground and landing at 100 knots in a crosswind and things like this. And this thing is running off coal at $1 a ton, which is like 188 gallons of oil per $1. So, I mean, these things were, they were brilliant. They were just energy brilliant. There's nothing that could compete with coal. So the only thing they could do is get rid of the coal burners. Now, let's say you took a coal train to San Francisco and you got there and, we weren't using petroleum. So, you might have to move around on a horse and a carriage. Like I said before, that wouldn't be such a bad ride, would it? Just as fast. But even in 1900, you could also have had an electric vehicle. You could have used the electric commuter train. You could have used alcohol-powered vehicles. And there were some gasoline-powered vehicle. You could have gone into San Francisco and ridden around in a white steam car. Could run off any liquid fuel. Or 1908, when the Model T came out, it was set up to run on alcohol. By the way, alcohol smells really sweet. I mean, compared to gasoline in a downtown area, there is no comparison. And they should have cleaned up gasoline. They should have never let us burn gasoline in the downtown area. Okay, so here's a simple still. I remind you, cars like this, you can make your own fuel with a device like this. And in fact, they were doing that. And as long as they were doing that, we were getting a much more clean burning fuel in the downtown sector. And they were using up a lot of their old material. They could use the old straw to burn and make heat. They could use the old crops, just about any part of the crop itself, to get ferment and get alcohol out of. Everybody should learn how to run a still. It's so simple, and it's such a valuable skill to have. Doesn't take that much equipment. And what you get is, frankly, something you can run a hospital off of. I know alcohol has nothing but a bad rep, but on the other hand, you could run your car off it, and you could drink it. I mean, come on. This is just a miracle product, and we don't use it, except just to abuse it. Really. Now here's some more stills. Alcohol production, as you can see, is much safer than refining petroleum. A heck of a lot more fun, too. So planet Earth never needed crust-produced petroleum. Somebody give me one good reason in the comment section. I know I'm going to piss a lot of people off. Think it over, folks. What have they done to us? All of this they developed in our oceans. Did they need to do this? No. Do we need to have them drilling into all these different layers? You know what happened down there in Louisiana, where they went into the salt mine, flooded that whole thing, created a disaster. We can produce all the oil we want above ground. By the way, hemp is one of the most intensive oil-producing crops. You've probably heard that George Washington insisted farmers use a certain amount of their land for growing hemp when he was president. And they have the gall, the industry has the gall to say that petroleum is a non-renewable resource. I mean, what could be a bigger lie? Well, here's a soybean kind of assembly line, and it shows the beans and how they're crushed, dried, conveyed, and filtered and turned into oil. So what do you mean petroleum is a non-renewable resource? You mean the toxic crud that comes out of the ground, that you might run out of that someday. That's not true either, though. Let's move on. Why am I going over this? Because we never needed to have this. This is Redondo Beach, California. This was the best place, one of the best beaches in the world. This warm water with fish in it, and look what they've done, okay? And now they're fracking. And this is even worse. The number of people's land that they have come upon and fracked now is just mind-boggling. You look at just one area of Denver. This is a place called Greeley, and look at all the plots in here that have been fracked. You know, all the groundwater here has been ruined. You know that, don't you? Now let's look at the oil platforms in the Gulf. What do you think this has done to the fish? All of these leak a certain amount. Some of them leak a tremendous amount. You add this number of platforms up, and what are you going to get? You're going to get a disaster. Well, we're sorry, they say. Yeah, we're sorry. We're sorry. We've burned all this up in the atmosphere, they say. And by the way, you know, we've all been paying an extra $600 premium on our cars so that we've got catalytic converters so that we do our share in maintaining a clean atmosphere. And this is how we get treated, where they don't even have to have a blowout preventer, and then they turn around and they're allowed to burn this off. It's just straight into the atmosphere. This undid all of our smog laws. It made them all pointless and worthless and nothing but a scam. This is what the industry leaves behind because we use a toxic fuel. Service stations with a land nobody wants because it can't be built upon unless it's reclaimed. And reclaimed, in other words, basically new dirt brought in to replace all the old dirt. And then we have the byproduct industries like the tire industry. This is where a lot of the toxic that can't be burned in the fuel goes into the tires, where it's worn off gradually, slowly into the environment everywhere on the planet Earth. And then when you're done with your tires, which can't be recapped anymore, this is where they end up. And these are really hard to reclaim. They're really hard to burn. They pollute so bad when you burn them, it is unreal. I've actually been to a tire burning plant, and it was disgusting how much cleanup it had to have just to produce 25 megawatts. So the peak oil statement is a farce. The fact is everything that the sun grows is a hydrocarbon, and running out of hydrocarbons is one of the biggest frauds of all time. But they're still pushing it. They're still teaching our kids in school that oil comes from dinosaurs that passed away. I'm not kidding. They're still teaching that. There's so many ways to make energy. Coal, animal fats, vegetable fats, sugars, alcohols, organic biomass material, gasification. So here it is. And this sources of energy, they say, oh, non-renewable. We got fossil fuels over here. We got coal, oil, natural gas. So we're supposed to be worried about this thing they call peak oil. Can we replace petroleum lubricants? Done deal. They've been doing this for, I don't know, 6 or 7 decades, making lubricants out of polyalpha olefins and polyalkylene glycols, diesters, polyol esters. So mineral oil is just one of many types of lubricant. Where are we at today? That's another reason why I'm bringing this up. We're still on this flawed teaching. Here is a state-of-the-art industrial marine engine. It's a Wärtsilä 14-cylinder that produces 109 1,000 horsepower. This is the engine in the largest container ship on the planet, known as the Maersk. Has one of these engines in it. And we're talking pistons that are 6 feet in diameter with a 10-foot stroke. And we're talking pistons that have to stop and turn directions and go the other way. We're still using this kind of intensely frictional kind of engineering mechanism. It is just insane. Well, okay, they're going to tell you we've really fixed this thing up. We've really made it state of the art because it has an exhaust gas economizer that generates steam for a turbine-driven generator. And that the turbine generator also includes an exhaust gas power turbine driven by a portion of the exhaust gases. So this is obviously something we should have been putting on, every piston engine from day one. Certainly we should be reclaiming as much exhaust gas temperature as we can on all of our piston engines. They all dump exhaust gas straight into the environment. We lose all of that energy. And so this manufacturer is able to tout that this engine is such a high efficiency engine because they've done all these things to it. Why aren't any of these applied to our cars and trucks? Well, we've also got ethanol from coal. We've got hydrocarbon-based ethanol shatters the paradigm, limiting ethanol production sources. It opens the doors to economical and efficient ethanol production without consuming arable land and competing with sources of food. We can make ethanol from natural gas. In the meantime, this is what we do with most of our natural gas. In the United States, we allow them to flare. We're still using gasoline. Irritating to eyes and skin. Causes dizziness, drunkenness, unconsciousness, absorbed through skin. Chronic, dermatitis, possible cancer hazard. Flammable, can form explosive mixtures in the air. It's toxic. It burns poorly. Carbon monoxide is one of the most poisonous gases on the planet. Gasoline produces that. It requires low compression engines so that they don't pre-ignite, detonate, make that funny noise. And that means low compression means always poor fuel consumption. If we can make alcohol from hydrocarbons, we can make alcohol from organic fats. We don't even need to ferment it. That's another route we can go. We can also do catalytic cracking at the oil refinery. We can also reclaim plastic by pyrolysis. Here's the inventor showing the whole process. He's stuffing this thing with plastic bags and Coke bottles and everything else, and he's producing a gas, and this is turning into a liquid. That's the whole unit right there. You turned into a liquid that you can burn in your engine. It's that simple. This is what it looks like at the industrial level. Fats can be converted to alcohol in the same manner that hydrocarbons are converted to alcohol. Now, ethanol via fermentation is very efficient, and it can also use residues or wood that contain cellulose or other long-chain hydrocarbons, long-chain carbohydrates, which can be hydrolyzed to fermentable sugars. And here's some charts on what do you get the highest yield from. We've got liters per hectare acre, which is about 2 acres. And with sweet potatoes, we can get almost 6,000 liters off of 2 acres. So let's move on. Production of seed oil by several seed oil crops. This shows you crops like sunflower, how many gallons of oil, kilograms per hectare acre of oil you get from these different types of plants. Lots of way to produce oil here on this planet. Fermentation is the most efficient, but it's not required. We could harvest fats and convert them to alcohol, but it would make more sense to use petroleum hydrocarbons, probably in this manner. We have methanol from natural gas. Here's a natural gas plant, West Virginia Oil and Gas. This is what it looks like when you use natural gas and convert it into methanol alcohol. This is not alcohol for drinking, remember? China, methanol production. In just the past 6 or 7 years, we've seen China's methanol production capacity rise from 5 million metric tons to 30 million metric tons. And it's mostly based on coal gasification. Coal is the primary feedstock in the Chinese market. Okay, during the Carter administration, they did a lot of research on making fuels from algae, and we convert the wet biomass into a combustible fuel by dehydrating it And then we use a solvent to extract the rich components like the triglycerides from the dried material. And once that's extracted, the compounds are then processed into fuel using standard industrial procedures. Products include oil, which can be refined into aviation fuel, gasoline, or diesel fuel. And from the National Renewable Energy Laboratory, the Aquatic Species Program focused on the production of biodiesel from high lipid content algae growing in outdoor ponds and using CO2 from coal-fired power plants to increase the rate of algae growth and reduce carbon emissions. So here's another thing we can do, continuing on using algae as fuel to produce one quad of biodiesel could be produced on 200,000 hectare acres of desert land. Now they figured out this was a total diesel requirement of the United States, that it could all be produced on 2,000 hectare acres, or 400,000 acres. Now, if we compare that with rapeseed crop, it would require 58 million acres, or 116 times more acreage to produce the same amount of fuel. So we need to get smart, and this is a way to really make a lot of fuel. We capture the waste CO2 because plants need carbon dioxide, animals need oxygen. So when we flood algae, which are plants with carbon dioxide, they grow, they convert all of that CO2 into growth. And everything that grows on planet Earth is a hydrocarbon. Remember that. So we're going to use algae for CO2 gas conversion. This is what the device looks like, where the exhaust gas is passed through a tank with a sloping lid, and the algae gets light and it gets carbon dioxide, and boy does it go crazy. I mean, it just grows like gangbuster. So why are we still using crust-produced toxic petroleum? When the gasoline piston engine was invented in 1885, it's now remained in service 133 years. There's only one reason: because of increased consumption of petroleum. It's a stupid design. It's designed to have lots of friction, lots of maintenance, and always consume way more petroleum than any other kind of transportation device that has been designed. So my suggestion, stop buying their stupid designs till they give us good ones. And that just means hang on to your existing car. Stop buying piston engines that only run on a toxic fuel. Demand a non-piston powered vehicle. We've had them. They worked great. We had the turbine, we had the Wankel, we had the electric, we've even had the fuel cell. So there's no excuse. It's time for a change. And I don't mean change to some downsized, unsafe ride. I'm talking about vehicles that have the same level of safety as an 18-wheel commercial truck. We deserve the same amount of protection as anyone else out there on the road. Yes, we are entitled to this reasonable level of security so that when we get in our cars to go somewhere, we know we're going to get there and not end up in a hospital. We also have the ability to demand a transportation system. It's time also to demand a transportation system that does not expose a person to any unnecessary risks. The way it is now, nobody is really safe. It does not expose the environment to unnecessary toxins. As it stands, all crust-produced petroleum is toxic. Imagine what kind of a transportation system we would have if we had one that served the people instead of one that served a corporation seeking profits at the expense of the environment. Dare to believe. Above ground hydrocarbons are non-toxic. There's no volatile organic compounds. There's no carbon monoxide. I say no smog. Basically, there would be no smog. But there would be no polluted rivers. There'd be no polluted lakes, oceans, farmlands, and cities. Thank you for listening and watching. Leave your comments below. Subscribe if you want more. And my name is Kenneth M. Price, Jr. I thank you for listening. I'll see you in the next episode.